Hey, this is Kobe Cooper speaking on behalf of Team 6 in the Engineering 122 class -002 for the winter quarter, and this is our project design video for our mobile AC. So the main issue that we were trying to find was temperature regulation outside for long periods of time where you can't really go just straight back inside to get hot or cold. And this usually helps with construction workers outside because they usually I work outside in sweltering heat for hours on end in the cold as well. And according to the National Institutes of Health, construction constitutes 36.8% of occupational heat-related mortality nationwide, and that is the most out of any outside working job that's out there currently. So that's a lot. So a lot of people in construction are falling out because of heat stroke or because of like hypothermia or stuff like that. So our idea was to say, hey, what if instead of just going straight back inside and wasting time, we strap on an AC to you that can control heat or cold. And we thought that an AC like something like this could help, but it's way too big. You can't just be going around carrying this around with you. It's powerful, but it's make you look dumb. You don't want to look dumb outside in front of your coworkers. So we decided to make this. It's small, it's compact, and we currently have these plastic set up. And to demonstrate that if you have something like a belt, you can loop it on to the bottom on these holes here so you can attach it to your belt so you can either have it outside or inside your shirt to blow cold or hot air. And how it works is that we have our two fans in the front and back, three thermistors in the front, in the middle canister, and the outside as well, right here. I don't know if you can see it too well. Right there. And then we have two resistor heaters in the middle of the canister to get hot air into that little space so we can blow it outwards. And then we have a switch relay that is controlled by this little remote right here. And of course, we have our Arduino in the front right here to control everything. So basically, how it works is that it has two modes, auto and manual mode. In manual mode, it will be controlled by the switch here. And if I press the A button, it turns on this back fan and the two little resistor heaters in the middle there, and those resistor heaters will heat up. And ideally, this canister right here will be closed off so the little canister will heat up and you can blow it out outwards for hot air. Or if you want cold air, you can turn the A button back off and turn the C button instead, so the front fan will go off instead. So that'll give you cold air, cold air. And right now we have it so that the front and back can be turned off and on separately. So if you want both on, you can, or if you want them both off, you can. And for auto mode, we have our Arduino detecting temperature with the three thermistors. If it's too cold, it'll tell the heaters to turn on. And if it's too hot, it'll tell the fans to turn on. And that'll happen automatically depending on what you want or what you need it to be at. And that is basically what our project does. And in terms of uh, what is it, engineering disciplines. This is mostly just mechanical and electrical engineering, mostly mechanical to see how do we implement all this stuff into the switch relay, how do we implement the Arduino into the switch relay, and how to power most of this stuff with just the power that the Arduino does give us, which is 5 volts. And that is basically what our project does. Thank you for